All right, welcome year 10. One of my favourite lessons of the year today, completing the square. A really clever technique that'll allow you to factorise any quadratic, even some of those tricky ones. We're going to have a look at that now. The important thing before we start, we need to know the two forms of a perfect square. If I have a plus b, I would usually write it, but they've got x plus a all squared. That's okay. First term squared plus 2 times the first term times the second term plus the second term squared. We know that because where does the 2ax come from? Oh, that's right. If I wrote this out in expanded form, if I had x plus a multiplied by x plus a, the x squared's obvious, and the a squared is obvious. But remember that 2xa, there's 1x multiplied by a there, and there's 1a multiplied by x there. So that's twice that I have the product of a and x. And that's what we're going to look at today. Now they wrote xa, I'm probably going to write, they wrote ax, I'm going to write xa, only because it's going to help you think about how to go about these questions. You can see when it's a minus sign, the only difference there is it's going to be negative 2ax because that product will be negative each time. It's still a positive a squared because, of course, a negative times a negative is a positive. Let's go ahead. They tell you a method here where you just decide what to add on. I'm not a big fan, as you would know, of just doing something because someone says you should. I want you to understand why you should be doing it. So we'll start with these examples and we'll see how we go. Here we've got decide what number must be added to these expressions to complete the square. So we want to make a perfect square. We want to make x squared plus 2x times some other number plus that number squared. That's really what we're trying to create. I always like to think of it as just a squared plus 2ab plus b squared, because we know that's a plus b all squared when we first learnt that expansion. And of course, if it's a minus, we'll include that too, because I think part b is going to include one with a negative. We want it to look like a squared minus 2ab plus b squared. The only difference here is they're calling ax. That's fine. If I want this to be a perfect square, I want it to look like something squared plus 2 times the first thing times some other number. Now this still has to equal 10x. So, well, obviously it's got to be 2 times 5. That would give me the 10, and then that term would be 10x. And so the term I want to add on is whatever that last little bit was, squared. So what number must be added to these expressions to complete the square? Well, you could write 25, but I'm just going to write 5 squared because I want it to enforce in my head, oh, that's right, that's what a perfect square looks like every time. Here I've got x squared minus 7x, so I'm thinking to myself again, oh, it doesn't like me using the pen now. I'll pause for a second and get my pen back. There we go, it's coming back. So this is x squared minus 2 times x times some other number. Remember, I want it to be in the form minus 2ab. So x is the a, so the b term, it's still got to equal 7. Oh, well, that's easy, isn't it? If I just make it 7 divided by 2, well then 2 times 7 over 2, the 2's would cancel. That'd be negative 7x. That'll work. So what's the number I have to add on? 7 over 2 squared. That would complete the square. Now, I want to be careful here. I've used equal signs there because usually what I do is I go ahead and I subtract that term again, so I haven't changed what it's equal to. At the moment, they've just asked what number needs to be added on, so that's the number at the end. I wanted to make it clear, though, they're not actually equivalent statements, are they? They're not equal to each other, so I better just write does not equal. But we can identify what were the terms that we needed to add on. 25 and 49 over 4. Okay, there's 2 for you to try there. Give yourself a minute just to have a go at those, then press play again and see how you went. And so rewriting that middle term as 2 times x times some other number, still had to equal 12 in the first one, so that other number had to be 6. Had to equal negative 9 in the other one, where we had negative 2, I needed 9 over 2. So the one you've got to add on, in the first one it was the 6 squared, in the second one 9 over 2 squared. Let's get to the actual factorising. So factorise these by completing the square if possible. I'll talk about that in a minute, but let's just see how we go first of all, trying to factorise these. So I want to rewrite this. I'm going to write it out again because you can't get tired of writing this. It's got to be in the form a squared plus 2ab plus b squared. And I'll use a little bit of colour to help our thinking here. So this is x squared plus 2 times x. It's supposed to equal 8x, so that other number must be 4. Now here's where I wanted to add on a number to complete the square. So I'm going to add on 4 squared. See how that matches the form now? It's something squared plus 2 times the first thing times the second thing plus the second thing squared. That's good, but this time I am interested in making sure these are equal because I'm factorising now. I'm not just finding a number to add on. I've cheated. I've added on 4 squared. Well, the only way to make sure I haven't cheated and I can still say equals is to subtract that 4 squared again later on. If I add 4 squared and take it away, that's not changed its total value at all. Now, you might be asking yourself, so why are we bothering to do that? Well, the reason we bothered to do it is now we can get a bit that we can factorise. Going back though, this negative 3, we haven't dealt with that yet. It's still got to be there. So you can see the bits in black, that's what we already had. The bits in red that I've added, they're the new bits. Now, why did I add them? Because this first bit is now in the form of a perfect square. There it is right there. That's the form of a perfect square. It's a perfect square because we can factorise that to just be a plus b all squared. So without thinking, that first bit now, I can just write as x plus 4 all squared. What are the leftover bits? Negative 3 minus another 16? Oh, that's negative 19. Now, you won't be surprised to learn that, as I said, one of my favourite topics, one of the favourite things to do in maths, completing the square, of course it's going to involve my favourite rule in maths, the difference of 2 squares here. Once you've done that first bit, you're now ready to finish factorising by using your favourite rule, the difference of 2 squares. 19, that's the same as the square root of 19 all squared. So I can just write this as x plus 4 plus the square root of 19 multiplied by x plus 4, that's my first term, minus the square root of 19. And now I've fully factorised that expression. Incidentally, when we go to sketching these quadratics a little bit later, that little form in the middle there, this is called the turning point form. Because it gives us the coordinates of the turning point of that parabola. That parabola would have turning points. The x-coordinate of the turning point would be negative 4. The y-coordinate would be negative 19. We'll look at that coming up, but there's just a little preview for those of you who are interested. If you want to think about why it might be the case, I'll leave that for you to think about for now, but rest assured, we will get to it. I want to do one more before you try yours. I'm just going to insert a little bit more space if it allows me, and I'll do B underneath here. I know this one's going on for a little bit. I'll try and wrap it up soon, but it's too much fun, and we have to talk about why they said if possible. So let's see what happens in this one. X squared minus 2x plus 8. Looks a bit like a 4. There we go. Make the perfect square. So it's the first thing squared. This one's got a minus. That's okay. So it's minus 2 times the first thing times some other number. Now, it's still got to equal 2x. Well, I've already got a 2 and an x, so that's just got to be a 1. So what am I going to add on? That's right, 1 squared. I've still got plus 8 there. But I can't say these are equal if I've added 1 squared unless I subtract 1 squared again. Now, just to make it clear what I've done, let's go back and put that in a different colour for now. When you're doing these yourself, there is nothing wrong with actually using a different colour there, just to keep your brain thinking about, oh yeah, that's right, that's what I'm doing. I'm just changing, I'm adding on something, but I'm taking it away. Why did I add it on? Because this first bit, I'm going to be able to factorise. I don't even need to think. It's x, my pen's playing off a bit, minus this time. Oh, 1's the other number. There you go. X minus 1, all squared. Now here I've got plus 8 minus 1. That's plus 7. And here's why they've said, if possible up here. What's my favourite rule in maths? What's your favourite rule in maths? Difference of 2 squares. I don't have a difference here. I have a sum. So at the moment, we can't go ahead and factorise this one any further. If you're thinking about this is the turning point form, I gave you a little clue before. The turning point this time is 1, 7. If you imagine a parabola with a turning point at x equaling 1 and y equaling 7, and the coefficient of x squared is positive, so it's a smiley face parabola. Ah, makes sense that we can't factorise it. Because if I can factorise it, then I let that expression equal 0, I'll be able to find the x-intercepts. This one doesn't have any, does it? That's why there's no way to continue that factorisation yet. We'll get into complex numbers next year, those of you who come along into HL Maths or Specialist Maths, and we'll have a look at how we can actually factorise that. But that's in the future. We just like to sow a few seeds there, keep you interested. If you want to ask about it sometime, happy to talk about it. But for now, it's just getting that procedure, knowing a squared plus 2ab plus b squared. That's what I want to create. Then I can factorise it. There are 2 there for you to try. Have a go at theirs. I'll come back with the answers, and then you'll be off to work on your own shortly. All right, good luck. All right, so I've got my answers there. Hopefully yours match. Complete the square. This one, yes, it will factorise because it's got my difference of 2 squares. X plus 3 plus root 10, x plus 3 minus root 10. The other one, once I've completed the square, I've got a sum of 2 squares. Not going to factorise, so I just leave it as it is. Nothing else I can do there. They've got a couple for you to try here. It's just got a fraction in it. It's not very hard. Another one that I would be more interested in you being able to do, and some of you are probably thinking about it, what about if I've got 2x squared plus 14x minus 3? How do I go about factorising that one? Well, what I would do first, that 2's annoying me. I'm going to factorise out the 2. X squared plus 7x minus 3 over 2. Now, I can go ahead and complete the square for the bit inside the brackets. The 2 just stays in the front there. Keep the 2 in front. Make my perfect square. X squared plus 2 times x. Oh, it's got to equal 7x. That must be 7 over 2. What number do I add on? Ah, that's right. I've got to complete that square. That's got to be 7 over 2 squared. I better take that away again. I don't want to forget to take that away again. But I'll leave a gap there because I know that I've still got my other part of that original equation, the minus 3. Now that. All right. Hopefully you've had a time to see what I did there and read that message. Thank you to the angel who picked this up for me. Silly me, after saying I was going to sort out that 3 over 2 later. I didn't. I just left it as a 3 again. I looked at the wrong line. Be careful you're following your working. Of course, this number here should have been 3 over 2. Now from there, we're going to be able to go and complete this nicely. If you're wondering where my face has disappeared, it's not because I'm crying tears over my mistake. We all make them. That's okay. It's because there are lots of people back in the staff room now. So I had to go and find a quiet classroom to do this in. Hopefully the microphone's working still. This first little bit in the square brackets, that's the perfect square we wanted to create. So it's going to be x plus 7 over 2 all squared. It's in the right form, a squared plus 2ab plus b squared, so we can just write it as a plus b all squared. Over here on the right, I've got negative 3 over 2, and the red bit, 7 over 2, when I square that, it's going to be 49 over 4. Why did I just pause on that 3 over 2? I can see this is going to be over 4. So let's write 3 over 2 as 6 over 4. Just multiply the top and bottom by 2 there. The reason I can do that and that it's useful to do that is now I can write that part as a single fraction. Whoa, stylus didn't like that. X plus 7 over 2 all squared. That bit stays the same. I'm trying to set up my favourite rule in maths here. Now I've got negative 55 over 4. If you want to take the extra line, take the extra line here if it helps you eliminate mistakes, which as you can see is a lifelong challenge in maths. I want to write this as a perfect square. So it's going to be root 55 over 2 all squared, isn't it? Just the square root of each bit there. All squared. Now I've got a squared minus b squared. I've got my favourite rule in maths. So I can go ahead and finish this. X plus 7 over 2 plus root 55 over 2 multiplied by x plus 7 over 2 minus root 55 over 2. All right, that should be a little bit better now. Thanks very much. Keep up the good work. As I said, there are a few little tricky ones in here. If you've got something like that, that would be towards the very end of the paper. This sort of stuff at the start, we expect you to be able to do without too many problems. Here, just got to be careful with the algebra. And then you can do that without too many problems as well. All right, keep up the fantastic work, Year 10. You're doing a terrific job. We will catch you in the next video. Thanks. Bye.